So this is a short segment on what we call alternating series. First of all, that let me remind you that all the tests that we learned so far, the direct comparison test, the integral test. Remember the integral test, I need f of x to be positive. I need all the terms to be positive, as well as the limit comparison test. That's what we covered in 11.4. All of those tests requires the term to be positive, requires the series to be positive series. So what if the series is not positive? Okay, what if we have some mixed sign there? Turns out right now, the only mixed sign situation that we can deal with is what we call alternating series. In other words, the signs keeps alternating. For example, positive, negative, positive, negative. You see the sign is alternating. For this one, normally I can represent this by a sign part that's simplified by a negative 1 raised to some power, followed by the positive part, which is 1 over n. If I use a power n here, where n goes from 1 to infinity, that's not going to work, because n equal to 1 will result in a negative sign. That's not what we have on in the front. And when it's 2, when you plug in n equal to 2 here, you'll get a 1 half, but negative 1 to the power of 2 will be positive, so that's wrong. So sometimes I put a plus 1 here. So now the sign will be alternating between positive, negative, positive, negative. So this component is the sign part, that component is the positive part. Here's another example. This one is also what we call alternating series, just because the sign is alternating. So there's a sign part. I'm going to use negative 1 to the power of n, so that the first term will be negative, the second term will be positive. And it turns out the positive part takes the following formula: n over n plus 1. When it's 1, you have 1 half. When it's 2, you do 2/3. Okay, so that's the formula for this alternating series test, for this alternating series. To check if alternating series converges or diverges, we have the following important alternating series test. That's actually pretty easy to apply. Okay, here's how it reads. Let's say this is how the series look like. There is the sign part, there is the positive part. I can write this apart. It'll be something like this. If this alternating series satisfies the following conditions. Number 1, the positive part is always getting smaller. The positive part always gets smaller. Like this guy right here, okay? 1 half, 1/3, 1/4, it's getting smaller. Number 2, if the positive part actually going to zero, that's all the 2 conditions you need to verify. Then you can say the alternating series converges. All right. So sometimes you can summarize this in a single sentence. You need the positive component to be decreasing, okay, decreases to where? Decreases to 0. Then the series will converge. So let me show you a couple of examples. example number 1. Show that this alternating series converges. Solution. Is it decreasing? So I want to say this is true. Okay, so this is true because this is a sub n plus 1, this is a sub n. So it's kind of trivial. This guy is always less than this. Checked. Number 2. Is it true that the limit of a sub n going to 0, which is 1 over n? That appears to be true as well. Thus, by alternating series test, the series converges. Okay, converges. Example number 2. So for this guy here, you can do some preliminary analysis. Forget about increasing or decreasing. Some of you might notice, wait a second, 4 minus 1, that does not go to 0. This guy goes to 3/4, right? So this is preliminary analysis. It goes to 3/4. So can I say by alternating series test, the series diverges? Now, however, notice we can't use this as a reason. I can't use alternating series test to say a series diverge, because alternating series test only gives you condition under which the series converge. It does not say what happens if those conditions are violated. It does not say under what condition the series diverge. So you can never say, hey, by alternating series test, the series diverges. That's not how it works. Alternating series test only tells you if those two conditions are met, that's when we can say the series converge, and for convergence only. So what might be a good reason to say, well, this one diverges? I have a feeling this one might be divergent. So here's the actual solution for this problem. Since, let's look at the limit of this term. I'm not just looking at the positive term, I'm looking at the whole thing. What can you say about the limit of this? Well, 3n over 4 minus 1, that goes to 3/4, but there's a sign in the front which keeps this guy oscillating between positive 3/4 and negative 3/4. So in fact, I can say this limit does not exist. Okay, does not exist. For those who are still wondering about this, you can go ahead and plug in some different n values and find out how those numbers actually look like. But this one does not exist. Thus, the series must be divergent. By what test? By test of divergence. Okay, test of divergence. Test of divergence says as long as this guy does not equal to 0, as long as the limit of this term does not equal to 0, then the series must be divergent. And that's what the test divergence says. All right. So even though this is an alternating series, we claim this one diverges, not by alternating series test, but by test of divergence. That's what I'm trying to say here. Okay, that's all I'm trying to say here. And one last example. So once again, obviously the key here is to show if the term is decreasing or not, and also calculate its limit. Let's look at this guy here. Solution. Based on what we were talking about, the key here lies on the positive component. So I will write this down. it becomes kind of clear that this guy will go to 0, probably decreasing as well, because when n gets bigger, this one gets bigger a lot faster. So I suspect this guy will be decreasing, going to 0 as well. But I have to show this. So that's the first thing I have to show. A sub n plus 1 is less or equal to a sub n. Remember, there are two different ways I can show this. I can do n plus 1 squared, n plus 1 cubed, n plus 1. Show this less or equal to this. And then do a cross multiply. Okay, do a cross multiply. This is straightforward, and everybody can do this. FOIL things out, you'll be able to compare this. Okay, so you can easily do this. So that's method number 1. So that's the approach 1. Okay. So here I like to practice a different approach, which is by take the derivative of the associated function. So I want to show this function is decreasing. Okay, I want to show this function is decreasing by take its derivative. So let f of x to be the associated function here. I'm going to calculate the derivative. Use the quotient rule. I can even take an x out. That's a 2 minus x cubed. So when do you think this will be negative? Well, its denominator obviously will be positive. So is this guy. It'll be negative when this part is negative. So I say this is negative if this is negative, which is equivalent to say x bigger than cubic root of 2. So my conclusion is the term will start decreasing when n is greater than this number. Okay, when n is greater than this number, greater than this number. This number is slightly bigger than 1, but not yet 2 yet. Okay, not yet 2 yet. So a sub n will be decreasing. Okay, a sub n will be decreasing. So that's why we can show it by using the derivative. Followed by calculate the limit, which will be kind of straightforward. Divide by n cubed. Divide by n cubed. 0 over 1 plus 0. So that's how you show the limit is 0. So indeed, the term decreases and going to 0. The series converges. Okay. So that is the alternating series test. Okay, that's the alternating series test. We're not gonna cover anything like alternating series remainder. So on the YouTube video that I posted, some of you may find the remainder estimate. We're not gonna cover that. Okay, this is the only thing that I will cover. That's the only thing we'll cover. So I'll write down a few problems for you guys to practice. I'll tell you the answer and you can think about this one, okay? So these are two practice problems. Think about the differences. I can tell the answer right now. This guy diverges. Think about how I can show this. Similar to one of the homework, similar to one of the examples that I showed you. This one will be convergent. All right. So this is the segment of alternating series test.